Hey guys, welcome back. In this particular video, we're going to be taking a look at the ASA firewall, an overview of the product, and also how the traffic flows are controlled on an ASA firewall. The main topics that will be covered in this particular video, we're going to go over the overview of an ASA firewall, where it evolved from, what are the different capabilities it has, the default traffic flow through the ASA firewall, and then take a look at the distinction between to traffic versus through traffic, and how do you control that on an ASA firewall. So to get started with, let's go ahead and take a look at where the ASA firewall evolved from. Cisco initially, when they had their first product as a firewall, it was called the Private Internet Exchange, or the PIX firewall. It was an appliance that allowed it the ability to act as a firewall. This is back in the 90s that they came out with that product. At that time, it was a firewall that did have some VPN capabilities for remote access. They could do remote access VPNs using IPsec, L2TP v3, or L2TP actually in general, and PPTP. The PIX firewall did not have at that time the capability of doing a VPN based on SSL. Whether it was the client-based or clientless. Client-based or clientless. So Cisco was looking for a product that they could integrate with their firewall device to give an end user the capability of doing both things, because VPNs were coming about and becoming the standard for a firewall to implement. So what they did was they went out and bought a company by the name of Eltiga. Eltiga at that time had a product by the name of the VPN concentrator. The VPN concentrator, the thing that was famous for, its main core component, was basically this. It was a VPN box, as the name suggests, and it had the ability to do SSL VPNs. It could also do IPsec VPNs. So initially what Cisco did was they sold the two products, the PIX firewall as the firewall product, and the VPN concentrator as the device that would terminate your VPNs, whether they were LAN-to-LAN VPNs or remote access. Remote access VPNs are your VPNs from your clients using SSL. So initially they kept on selling it as two different products, the PIX and the VPN concentrator. And then in the early 2000s, they combined the capabilities of the two products into one, called the Adaptive Security Appliance, the ASA appliance, which basically was a combination of the firewalling capabilities of the PIX firewall and the VPN capabilities of the VPN concentrator. And that's what the ASA firewall is all about. So ASA firewall gives you the capability of acting as a full-on firewall with the capability of supporting VPNs, which it got from the VPN concentrator product. Now, needless to say, once the ASA became popular, these devices became end of life. They were taken off the shelves, and the only product that they were selling and are still selling is the ASA firewall. All right, so that's a little bit about where the ASA came from. So that's what I'm doing in the first video over here, that talking about the first physical firewall being the PIX firewall. The firewall had limited VPN capabilities. The web-based VPN were not becoming popular at the time. The PIX firewall did not have the capability of doing that. Cisco acquired another company by the name of Eltiga, and Eltiga had that device called the VPN concentrator. The main thing that it was known for was the web VPN capability. They integrated that VPN concentrator capability with the PIX firewall capability, and that's where the ASA was born. So the ASA is basically a combination of your PIX firewall, the firewalling part of it, and the VPN capability from the VPN concentrator. All right. Now, what is this ASA firewall? Essentially, it is just like your router. You do have the ability to make it as a layer 2 device, but when you get it from the factory, by default, it will act as a complete layer 3 device. It actually nowadays has the ability to run RIP, EIGRP, OSPF, and now you can even run BGP on the ASA firewall. Obviously, static routes are always there. Besides that, the dynamic routing protocols you can also run on this ASA firewall. So it's essentially a layer 3 device, just like a router. But unlike a router, where once routing is established on a router, all traffic is allowed through the router. The firewall is a security device. Yes, it does need to have connectivity that is established based on the routing, but in terms of access, what type of access is given through the firewall, that is not done automatically. There are certain rules that need to be followed for traffic to be allowed through the firewall, but it in essence is a layer 3 device. You do have the ability to turn this layer 3 device into a layer 2 device, which can also act as a firewall, which is called a layer 2 firewall. We will be covering that in this video series about ASA. This type of firewall in Cisco is known as a transparent firewall. So essentially it's a layer 2 device, so you have the ability to put it in the middle of your IP segment and do firewalling with it. We'll be taking a look at that as well, but predominantly the Cisco ASA is a layer 3 device, a router with full routing capabilities. But in terms of traffic flow, we'll take a look at how traffic flow is governed by the ASA. So it's not going to allow all traffic to flow through. There is certain traffic that is allowed, certain traffic that's not allowed. So coming back over here as an overview, it is a layer 3 device, has all the normal functionalities of a router running RIP, EIGRP, OSPF, BGP, and static routes. So it also has the ability to do static routes as well. We'll do labs on that as well. The difference between a regular router and ASA is that by default, the router will route all the traffic, ASA will not. It has certain policies that need to be adhered to that you will take a look at as we go through the video that will govern what is the default flow of traffic through the firewall. Actually, it's a core component of this particular video. Now, in order to do that, there are certain things that are different on the ASA firewall from a router. Normally, when you configure a router interface, you just need to assign it an IP address and bring the interface up. So let's say it's a router, and you want to bring a router up, the interface of a router. So you say interface E0/0, IP address, assign it an IP address, let's say 192.1.20.10.255.255.255.0, and do a no shut on it. That's how you bring up an interface on a router. Now on the firewall, the same thing is done a little different. You do need to assign it an IP address. So if this same address was to be assigned on a firewall, you would do the same command. But besides the IP address, there's two additional components that you need to configure on an interface on an ASA firewall. These two components are required components besides the IP address. Number one is the name of the interface. This name of the interface is what commands on the ASA firewall reference the interface with. They don't point to the interface using E00, they'll use the name of the interface to reference it. So all the other commands that follow that pertain or point to the physical interface, they'll use the name of the interface. For example, on a router, when you create an ACL and you want to apply the ACL, you apply it to E00. Here, when you apply the ACL, you're not going to apply it to E00, you're going to apply it to the interface name, and that's done by using a command called nameif. We'll go into details about the commands. Let's say this is the outside interface or the external interface. You give it a name. So now if you want to apply an ACL, you're not going to apply an ACL to E00, you're going to apply it to the interface called external, which points to E00. So the name is a required component because all the other commands will point to the name, not to the physical interface identity. The other one, which is even more important, is what is known as the security level. Another required component. Security level determines how secure is traffic on this particular interface. Is this something that I control? Is it trusted or is it untrusted traffic? The most trusted traffic is traffic coming from an interface with a security level of 100, which is the highest security level. And the lowest security level, the one that I don't trust at all, generally the internet, is a interface with a security level of 0. So you determine the trustworthiness of an interface by specifying this security level. And this security level, which we'll take a look at in detail in the next few slides, is the one that determines the default flow of traffic through the firewall. All right, so this is another very important command that you need to specify on the interface for it to come up, which is the security level. There is no security level by default on an interface, so you need to assign it. Now the thing is, in order for you to have an interface up and running, you need to have a name if and a security level. So let's say you have a blank interface and you assign it a name. By default, it'll set the security level to 0 for all the names except for a special name, and we'll discuss that again in detail later on, the word inside. If you call your interface a name of inside and it's a blank interface, it does not have a security level on it, it'll default it to 100, the most secure. So this is a special name. So if you use the word inside, it'll set the security level to 100. Any other name, if the interface does not have a security level, it'll set it to 0, but there's no security level by default. This is when you give it a name that it'll set the security level to 0 or 100 in case of inside. Any other number or any other name will set it to security level of 0. Now the the name of the interface, it is not case sensitive for the most part. So whether you type in inside in uppercase, lowercase, mixed case, it doesn't matter. If you use the word inside and it's a blank interface, it is going to set the security level to 100. So it's not case sensitive. There are certain commands that do point to the interface that need to be in the right case, but most of them, 99% of the commands, it is not case sensitive. So to recap, if I wanted to configure an interface on the ASA firewall, besides having your normal IP address assigned to it, you also need to give it a name. And if you don't specify the security level, it'll default the security level as soon as you assign it a name to 0 unless you use the word inside. And then you do the no shut command. So that's how you initialize an interface on an ASA firewall. Now the security level plays a big part in the default traffic flow, and we'll discuss that as we go through it. So let's take a look at the slide over here. So we talked about besides assigning the IP address to the interface, the ASA requires 2 additional parameters on the interface. We'll discuss that in the next slide. So right over here, what are the different configuration parameters that are required on the interface? As I said, you need an IP address, which is normal. All right. Then you have the name of the interface. It is a required parameter. The name of the interface is not case sensitive, although there is a certain command, the command we'll talk about later on, it's called the crypto map command. For that particular command, it is case sensitive. For the other ones, it is not. Although it's not case sensitive, it does preserve the case. What does that mean? Let's say initially when you're configuring the interface, you set the interface as E00 and you said name if inside with I capital NSIDE in lowercase. So later on when you point to it, let's say you want to apply an ACL to it, and you apply the ACL to the word inside with I lowercase. When you type it in, you applied it to inside, you'll go back into your running config, you'll notice that it has changed the case back to inside to match the case. If it was case sensitive, it would not even take the command, which it doesn't. As I said, for crypto map, it doesn't. But for all the other commands, it'll just convert it over. It'll preserve the case. All right? So from this point on, like I showed you, the ACL, whenever you need to apply any of the parameters to the interface, you don't apply it to the physical ID, not to E00. You're going to apply it to this name. So it's an important parameter on your ASA firewall. Now, what happens when you assign a name to an interface and it doesn't have a security level? It'll default the security level to 0 for all the names, except for what? If the interface has no security level and you give it a name, if you give it a name of inside, any case, uppercase, lowercase, mixed case, it will set the security level to 100. Anything else, it'll set it to 0. What is the security level? It's a number between 0 to 100. This is a very important parameter. This is the one that will control what traffic will be allowed through the firewall. We'll take a look at that in the next coming slide, which is a very important aspect, the core aspect of your ASA firewall to secure your traffic, which is coming from an untrusted interface towards a trusted interface, whether it's allowed or not. When you configure a blank interface with a name, that is this guy, it sets a security level to 0, except for when you use the word inside. So the only one that it sets it to 100 is the word inside, and it doesn't matter what case, inside, outside, inside, in uppercase, lowercase, or mixed case, doesn't matter. So again, to recap, what are the 3 parameters required on an interface? IP address, security level, and name if, besides the no-shut. Now, the IP address, there is something that is nice about the ASA firewall. Let's say I was setting an IP address of 192.1.20.10/24, which is the default mask for this because it's a class C. The ASA recognizes that. So if you want to assign this address to your interface, although you do have the ability to type in the address, if you don't, it will take it and it'll apply the default mask for this class, which is /24. So when you go back into your running config, you'll see it magically would have set the mask to 255.255.255.0, which is the default mask for this particular class. But let's say you wanted to set 10.11.11.10/24. This one, I could not omit the mask, because if I don't put the mask in and I put the IP address as 10.11.11.10 and I press enter, it'll take the command, but then when you go back into your running config, you'll see the mask as 255.0.0.0 because it's a class A network. It puts a class A default mask. Default class mask, so it depends on what class you're assigning the IP address to. It'll put the mask based on that. All right, so in your interface, you have 3 parameters rather than just one that you need to specify. These are the 2 additional ones which are required. The interface is not up unless you specify these 2 parameters. Now, again, as I said, this is a very important parameter, and that's what we're discussing in the next slide over here, which controls your default traffic flow. Now, when you have 2 interfaces, let's say they have, let's say you have 2 interfaces assigned to your firewall. One is the outside and one is the inside interface. So you have an outside interface and you have an inside interface. Outside is the untrusted one connected towards the internet, and the inside is towards your corporate network. You have a security level set to 100. When you have that, what you've configured the IP address, let's say you've done the routing, you maybe probably put a default route towards the ISP, all that is done, so your connectivity has been established. But now what traffic will be allowed to go through the firewall by default? Now by default, all traffic going from a high interface, high security level interface, to low is allowed. So people on your corporate network have the ability to go out to the internet. Not only can they go out, the return traffic, when it went in from out, when the traffic was allowed, the firewall does stateful inspection and inspects all TCP and UDP traffic going out. This is called the implicit inspection. It's done implicitly. You won't see a command for it, but it's there. This implicit inspection will inspect TCP and UDP traffic, create a state entry, so when the return traffic is coming back in from the internet, it's going to check this table. It's called the state table or the connection table, and in the connection table you will see the return entry, which was created when the traffic was allowed from a high interface to the low interface by default. So by default, all traffic going from high to low is allowed, and not only that, it's inspected, but it's only inspected implicitly for TCP and UDP. So if you sit on the inside and try to do a ping, although the ping will go out because all traffic is allowed from high to low, because it was not inspected, there won't be any entry for the return traffic, so it will be blocked coming back because there's no connection entry. Now, How do you allow traffic coming from the other side, low to high? I don't need it for return traffic, but let's say I did have my firewall with a web server on the inside. Generally, you won't put it on the inside, you would put it on a DMZ network. But let's say I'm allowing it from 0 to 100. I want to allow people coming in from the internet towards my web server. I need to create an ACL. The ACL, you would need to explicitly allow traffic initiated from where? Initiated traffic. This is when traffic is coming in from where? Low to high. So by default, all traffic coming from low to high is blocked. If you do want to allow it, you need to explicitly do a permit statement to allow that traffic that is initiated from the outside to come in. The ACL will also help me for that ping traffic. So if I did a ping from in to out, it would have gone out because it went from high to low, but because it was not inspected, so the return entry is not in the connection table. So when it tries to return, it's not going to be allowed. So on the return, it'll check the connection table. It's not there. And it's coming from low to high. So that's blocked by default. Connection table is not making an exception. So then it checks in ACL. If there's no entry in the ACL as well, it'll block it. So if you did want the return to get allowed the ping to return, you would need to put an explicit entry for ICMP as well. Later on in the course, I'll also show you how you have the ability to, although implicitly ICMP is not inspected, you do have the ability to turn that capability on so that even ICMP gets inspected. But by default, it's not. Only TCP UDP traffic is allowed. So to recap again, what happens to the default traffic flow? Traffic from high security level to low is allowed. All traffic is allowed. And what is inspected? TCP and UDP inspected. What do I mean by inspected? It creates a return entry. So the return entry, although it will be coming from low to high, the return traffic, it'll check the connection table and it'll see a connection saying this is return traffic. This was generated from inside, it's returning, let it come through. This is put in your connection table. So on the return, if it's coming from low to high, it says block, but let me make an exception if it's in the connection table, or the other exception is the ACL. How about if traffic is initiated from low to high? The default action is block, but you can override it by looking at the connection table first. If the connection entry is there, it's return traffic, it's allowed, or you can put a permit statement in the ACL to allow it. All right, so high to low allowed, TCP inspected, so the return traffic allowed, TCP and UDP inspected, so the return traffic allowed. Low to high, if it's not inspected, you need to put an ACL, or for any traffic that's coming from low to high, you can put an ACL to override the default, which is to block low to high. The return traffic will be in the connection table. Now, what happens if you have two interfaces with the same security level? So let's say I put this as 50 and put this as 50. This is my firewall. If you have two interfaces that are the same security level, by default, the behavior is, I don't want these two interfaces to talk to each other at all. Even an ACL in that case will not help by default. So if you have two interfaces that have the same security level, the traffic will be blocked, and even an ACL will not help. You do have the ability to override the block. We'll do a detailed discussion in the next video on that. But for right now, by default, when you have two interfaces with the same security level, all traffic is blocked. Even an ACL will not help you over there. You remember from low to high, you can make an exception by explicitly allowing it in ACL. But if you have two interfaces with the same security level, even that traffic within ACL will not be permitted. So this is something that you would do when you don't want two interfaces to talk to each other. All right, so that took care of this guy over here. Let's recap this. By default, all traffic is allowed from low to high security level as long as the routing information is placed. That's the connectivity part of it. Although all traffic is allowed to flow from high to low, only TCP and UDP traffic gets inspected. I explained that to you guys. It creates a connection entry. So the return entry, which will be coming from low to high, is going to be allowed. Inspection creates a return entry in the connection table. This allows the return traffic to come back. This is known as stateful inspection, and that's what we've done. I'll just make a small correction over here. It's known as stateful inspection. The name of the interface is not KSIT. This has nothing to do with this. All right. This is done. How about low to high? By default, all traffic is blocked from coming in from low to high. We talked about that. You can make that exception by explicitly creating an ACL and applying it to your interface to allow traffic from low to high. And not only that, if your packet comes as a return traffic, it first checks the connection table. If the connection table doesn't have it, checks the, ACL. If the ACL doesn't have it, checks the security levels. And if none of them have it, it's going to block it. All right, so that is the default traffic flow through the firewall. I also explained the same security traffic, which will be discussed over here. Actually, I think I do discuss it over here. Same security level interface. By default, any traffic going from an interface that has the same security level as a destination will be blocked. Even an ACL will not help in that case. Typical example of this setup is when you have two partner networks connecting in. So for example, let's say you had your firewall connecting in through a private WAN, maybe an MPLS network, to one of the partner, let's say partner 1, and another interface connecting through another MPLS network to partner 2. I want them to connect into my, let's say, my server network, the DMZ network, but I don't want them coming in from where? Coming in from here through me going to each other. So if I don't want that to happen, and even by accident if I put an ACL, I don't want that to happen, but this has 50, any number, I'm just using 50 as an example, you can put any number, as long as they match, traffic will not be allowed to go through, even if by accident I put an ACL. There's a way to get around that, but we'll take a look at that later on. And that is actually, I mentioned that over here. If you have the option to disable it by using the same security traffic permit inter-interface. If you use the above command, it allows all traffic between the two interfaces with the same security level. Now you can control it based on an ACL if you want to. All right. So that takes care of the default traffic flow, high to low, low to high, and if it's the same security level. The last thing in this particular video that I want to discuss is your to traffic and through traffic. Now the ACL and the high to low, low to high that I'm talking about is traffic that is traversing through the firewall. So I have an interface over here, another interface over here. This is my outside network. This is my inside network. We talked about high to low, allowed, low to high blocked, and you have an ACL that allows the traffic or makes an exception to allow traffic from low to high. All this is for through traffic. The entire discussion was only for through traffic. It does not pertain to any to traffic. What is to traffic? If somebody wants to hit a service on my firewall, to the firewall, the destination of the packet is a firewall interface, whether it's from the outside, whether it's from the inside, whether it's from a DMZ network, it doesn't matter. The destination is the interface. It's not through the firewall, it's to the firewall. That traffic is not controlled by an ACL. The ACL will have no effect on to traffic. So how do I control to traffic? It's done by turning on the service, the protocol on the firewall. Because it's destined to the firewall, the service needs to be running. For example, if somebody wants to telnet to the firewall, telnet service not running by default. So it won't allow telnet coming into the firewall. You would need to enable the telnet service. It's not through the firewall. If it's going from somebody wants to telnet into a device over here, that's through traffic. That would be running an ACL. But if you telnetting to the firewall, the service needs to be running because I'm setting the packet destined to the firewall. The only service that's on by default is the ICMP service for testing purposes to see if the connectivity is there. So by default, anyone and everyone can ping the firewall from the outside to the outside interface, inside to the inside interface. You cannot go through it, but to it you can. So outside can ping the outside interface, inside can ping the inside. If you happen to have a DMZ, the DMZ devices can ping the local interface over here. That is controlled by the ICMP service. So that's not controlled by the ACL. Even if you put an ACL saying deny ICMP any on an interface, that is only for through traffic. It's not for to traffic. To traffic is controlled by the service called the ICMP service. Similarly, if I want to telnet into it, it's not done by using an ACL. You need to use the service. Turn it on, control it using the service. All right, we have specific labs that I will go through and explain and show you how to traffic works versus the through traffic. All right, you'll get a chance to see that. So that's what this slide is explaining to you guys. To traffic is traffic destined to the interface of the firewall. It is controlled by the service running in the firewall. ACLs will have no effect on the traffic flow. This is something that is not understood properly by network administrators. So they think by putting an ACL on the interface, you're blocking the traffic. To traffic, ACL does not even look at to traffic destined to that interface. It is a service. So if it's a ping, ICMP is a service. By default, the only service that's enabled by default, as I said, is what? ICMP. Any other traffic, ping, telnet, SSH, HTTP, all those are services that you need to enable. And when you enable it, you need to enable it per interface. So if you want to enable SSH, for example, you need to specify that I want to enable SSH on this particular interface. By enabling SSH, it does not give you the capability of globally enabling SSH. It has to be done on a per interface basis. All right. So if you want to enable telnet, again, you need to do it per interface. HTTP, the same thing. If you want to terminate and VPN on the ASA, you again need to enable the VPN protocol, whether it's SSL, whether it's IPsec, you need to actually enable it on that interface that you're expecting to receive a VPN connection in. All right? So that's to traffic. And that's what I wanted to cover in this particular video. Let's recap what are the main things that we covered over here. Number one, where the ASA come from? ASA is a combination of two devices. What are the two devices? The PIX firewall and the acquisition called the VPN concentrator. This gave you the VPN capabilities. This was a firewall, and this is what the ASA is all about. ASA, in terms of the interface configuration, I need the IP address, which I normally need on a router interface. Besides the IP address, I need the name of the interface, and I need a security level which controls the traffic flow, the default traffic flow. It is an ASA by default is a layer 3 device, which you do have the capability, if you want to, make it into a layer 2 firewall. We'll take a look at that as well later on in the video series. We took a look at that. We looked at the default traffic flow, which is this guy over here. And what did we find out about the default traffic flow? We found out that high to low is allowed by default. Low to high is blocked by default. You also have same to same, which is also blocked by default. And how do I make an exception to traffic flowing through the firewall from low to high? It is done by using an ACL. All right. The ACL, although it controls through traffic, it does not control to traffic. That was the last bullet or last item that we talked about. If you want to control to traffic, it is done by enabling or disabling a service. By default, all the services are disabled on the firewall except for ICMP. By default, the only traffic that you can use to send towards the firewall to the firewall is ICMP. That's for testing purposes, to make sure the firewall is up and running at the time that you configure it. Other than that, all the other services are blocked. Now, this was the first video in the series. So the next one, we'll go ahead and initialize the firewall from scratch. We'll just set IP addresses on it, be able to ping the directly connected interface around the firewall. We'll do a lab on it, and then we'll slowly progress and do the other functionalities like routing. We'll do ACLs. We'll do this through traffic. We'll do NATing, a whole bunch of other things, virtualization. It's a good video series coming up. All right. Thanks for joining, guys. See you in the next series, the next video. Bye now.